Welcome to VINDAL'S concept, and today we want to look at definition of radioactivity, a small history of radioactivity or the origin of radioactivity, and then we talk about the concept of alpha decay and how to write the equation. Now, in 1896, there is a man called Henry Becquerel. He's a French physicist who first discovered that there are some elements on their own emit a kind of radiation. And when he found that such element exists, because of the instability of the nucleus of the element, that means they are not stable. So after some time, they emit some kind of radiation in forming a new element. And he calls such kind of element, they call them radioactivity. And then 2 years later, a husband and a wife called Maria Curie and Pierre Curie, they also went further to find out that there are other kinds of elements, which is also called radioactive. He found polonium, just like Henry found uranium, he found polonium and then radium, that these elements also can also emit some kind of radiation. And those radiation are what we call today as either alpha particle or beta particle or gamma ray. Now, further that, they now came up with the fact that radioactivity is defined as a spontaneous disintegration of the nuclei of an atom by emitting alpha, beta, or gamma ray, and which lead to the forming of a new element by the release of a heavy amount of energy. And that is what this radioactivity is all about. Now, let's talk about what is alpha decay. This alpha decay, which is one of the elements that was emitted on the process of radioactivity or during radioactivity, one of them is called helium atom, and this helium atom is the same thing called alpha, which is one of the elements that was emitted. Now, this element that was emitted, remember that this emission is caused as a result of the instability of the nucleus of these atoms. Now, if we have an element, let's say for example an uranium, or let's say any element which has this A and this Z. This A is the atomic mass and this is the atomic number, or this is the mass number of the element and this is the atomic number. The mass number A, atomic number Z. So whenever this happens, then there is a new element formed such that because of this alpha decay that it is emitting on the process of this radioactivity, the new element is going to reduce by 4. That is, the mass number is going to reduce by 4. Then the atomic number is going to reduce by 2. Then with the release of energy. So that energy is released whenever alpha decay occurs. Now the question should be, this energy that is released, what is it used for? Have they been able to harvest or harness the energy from this alpha decay? And that is a question we may answer at the end of this lesson. But then, if you check this, you look at this new kind of radioactive equation, whereby this is called the radium. Radium has atomic mass, which is 226, and atomic number, which is 88. Now, it undergoes an alpha decay. It emits this alpha decay. When it does, what happens? Something leaves it. It forms a new element because of the instability of the nucleus. It forms a new element, and that element is called the radium, which has atomic number of 222 and atomic mass, which has a mass number of 222 and atomic number of 86 with the release of this energy.